This week, we are pleased to have Joshua Snoke from RAND, who's a statistician there. He researches statistical data privacy topics, including evaluating and generating synthetic data using differentially private algorithms, equity and privacy. He's worked on privacy applications for administrative data and survey data, and recent projects include developing the validation server for accessing administrative tax data from the Internal Revenue Service, as well as creating synthetic data for the National Science Foundation's survey of earned doctorates in the longitudinal study of aging in India. He also serves on RAND's Human Subjects Protection Committee, somewhat akin to an IRB, and on the American Statistical Association's Committee on Privacy and Confidentiality. So lots of very cool privacy happenings. So I will let Joshua take it away.
Awesome. Thank you. It's great to be here. I'm going to give a talk that's not super technical today. I'm going to be talking about some work or some ideas that have come out of work on differentially private interactive query systems, and really getting into the question of, can we practically use them in reality? I already got an introduction, but I'll just say, I work at RAND, which is literally 2 blocks away, if you don't know. Our headquarters are in Los Angeles, but we have an office here. It's a nonprofit think tank. We do public policy research largely. You can also do methodological research there, but really our focus is on kind of bringing rigorous research into the applied realm. We work for a lot of government sponsors. And I, in particular, work on mostly statistical data privacy, also some algorithm-aided human decision-making stuff, algorithmic bias kind of stuff, and I'm really interested in bridging kind of these gaps between the theory and practice. So a few disclaimers about this talk. I'm going to give a talk that raises a lot more questions than provides answers. I'm going to kind of assume as a starting point the differentially private framework. I'm actually not really going to give a recap of that because hopefully most people here know what it is. But if you don't, stop me and ask questions that are relevant and I'll answer them. Do that through the whole talk, please. But my goal is not really to necessarily question the framework of differential privacy, but really to point out issues in the practical application of differential privacy in particular contexts. And so really in this talk, I'm hoping to kind of convince you that there are some maybe often overlooked issues that we have to work through. Really, I would say I'm going to be outlining a number of research projects. So if you're students or thinking about staying in this field, if you're interested in differential privacy, I would say there's tons of questions here that you could work on. And then lastly, because I am really at heart an applied researcher, inspire you towards, I would say, solving problems that really exist, right? Like a lot of the problems that I work on are motivated by trying to actually build something and then seeing what goes wrong and what's not possible. This work really is done with a lot of other people. It's not just me. So in particular, shout out to Ludus Panavas, who's a PhD student in Northeastern who worked with me this last summer, as well as a team of folks who are at the Urban Institute, who I work with closely. Okay, so I will say, I'll start off by saying what is a differentially private interactive system? This can also be called maybe a query system or a validation server in different contexts. But really all it is a system where someone, say data users we'll call them, maybe researchers, they come to an interface and they are going to submit certain queries to the data that's sitting, in the background. Before they receive the answers, those queries are going to go through some kind of noise. If it's differentially private, then it's going to be, the noise is going to be added under certain definitions. And then they're going to get the results back and run their analysis. That's kind of the idea of the interactive system. And this is in contrast to what is called a non-interactive system. So in the interactive system, you're thinking about privacy loss on a per query basis. So every time I ask for, say, a statistic or a particular output from the data, then I'm incurring some kind of privacy loss, and I'm accounting for it that way. and everything is being initiated by me, right? I'm going to the database and saying, or to the interface and saying, this is what I want returned from the database. The non-interactive setting, you can kind of think of, the simplest case is the administrators release a data set to the public, right? So in this case, there's not a sequence of queries initiated by a user. There's a sequence of queries initiated by the people who are controlling the data, and then they're generating, say, a microdata set or a set of maybe tables or statistics that they're releasing based on that data. And they're going to think about a per release privacy loss. So kind of everything they're releasing all together, because they have control of that. They're not waiting on people to come and interact with the system. So the interesting thing is that non-interactive systems really are, I would say, currently dominating. This is a rough count based on Damien, who I think is coming to talk in a few weeks. So I'm sure he'll be great. But if you search out there, this might not be the exact number, but there's a bunch of non-interactive deployments. A lot of tech companies use them. The U.S. Census Bureau has used it. It's a pretty common way at this point of applying differential privacy. And there's really, as far as I know, only one active interactive deployment, which is from LinkedIn. So at this point, we're really kind of shifting towards the non-interactive system. But what's interesting is if you go back and you look at kind of one of the the kind of beginning paper of differential privacy, or the one that really launched everything, from Cynthia Dwork and the co-authors, they actually talked about both the interactive and the non-interactive setting, and they pointed out a very correct observation. You don't have to read this whole quote, but they basically, if you look at the end there, it says, a non-interactive mechanism must be tailored to suit certain functions to the exclusions of others. This is not true in the interactive setting. And their point is basically, if you're trying to return the most accurate results for the queries that people are submitting, you're going to do better in the interactive setting. I think the question then is, well, why do we use non-interactive systems? If they made that observation 20 years ago, why are we seeing this? And simply put, interactive systems are hard. And I'll, the first kind of half of my talk is going to be trying to convince you why that's true. Okay, so if I'm going to convince you why it's hard, why do we even care about interactive systems, right? Like if everyone's just using non-interactive systems right now, if that's what all the tech companies are doing, and I'm about to tell you all the reasons why it's hard, why should we even bother trying to think about interactive systems? I think the first thing is that the comment from 20 years ago is still true. There are real limitations to non-interactive deployments because they require you to determine, in advance, a priori, what you're going to preserve in the data. And you're going to have to determine ahead of time what people actually care about when they're going to use the data. And so, you might miss something. And in the context I work in, which is really thinking about, social science, public policy researchers, I would say I see pretty significant skepticism in that crowd towards public data. And one caveat here, the asterisk, is they're skeptical when it's transparent how the data are actually noisy, because there are lots of public data sets that people just use as if they're not noisy when they are. But I'm kind of putting that aside. So in the context where you've told someone that you've done stuff to the data to protect it, people are generally pretty skeptical of, say, a synthetic data set or some other kind of public data file where you've, as the administrator, made all the decisions about kind of what queries you're going to preserve, what value you're going to preserve in the data. I think a large part of this is that the interactive setting does offer the opportunity for targeted analysis. So, if someone knows exactly what they want, exactly what they're interested in asking, they are going to do better, unless you happen to have also, preserved exactly what they wanted, which is unlikely. But then the last thing I'll say is, crucially, this is only true if the results actually enable valid statistical inference. And I'll talk more about that later, so I'm going to kind of leave that out there just for the moment. And then the last thing I'll say is, in terms of why we should care about these systems, and this is also the world that I live in, which is the federal statistical system. The federal statistical system is really investing in what they call a tiered access approach. So this is coming from a National Academy of Sciences Engineering Medicine report, where they basically talk about, we need multiple different types of data sharing and data access. We need, public data sets. We need what they call validation servers, which is an interactive system. We need restricted access where people are accessing the unperturbed data through some kind of secure system, and maybe some kind of legal agreements, right? Like all of these are going to be crucial because they all serve different purposes. So at the end of the day, even though, as I said earlier, there's not a lot of deployments of interactive systems, people are still really identifying them as crucial to kind of the data infrastructure. Okay, so now I'm going to dive back into kind of why interactive systems are hard. And I would kind of say that the issues fall into two main buckets, my first two bullet points here. The first one is what I would call misalignment between the mechanism design and statistical methods. And then the second one, which I'm going to spend more time talking about today, is unrealistic assumptions about the users of these systems. And I will say, the target audience that I'm thinking about here, again, is users of federal statistical data products. So these are going to be people who, use traditional statistical methods. They're also going to be people who want to, use the results of their queries to inform public policy. But I would say a lot of the issues that I'm going to talk about are relevant to other contexts. And I think it's partially why, again, we only see one live deployment, even by tech companies. Okay, so to go into the issues, starting off with what I call the idea that mechanisms are unaligned with statistical methods. This is, I think a lot of this has come out of the use cases that people are thinking about when they develop these mechanisms. And probably 90% of people who work in differential privacy are in the computer science engineering world. And so they're thinking about different types of queries than people in the statistical world think about, especially if you're thinking about social science. And so there's a lot of work for prediction problems or what I call simple kind of count queries, maybe univariate statistics. But there's really much less work for regression-based inferential methods, things that you would see in statistics, sociology, economics. There's I could probably count on one hand the number of papers that talk about causal inference and differential privacy. Right, there's very little looking at those types of analyses. And then the second thing is that a lot of the mechanisms assume a pretty well-behaved data generating process. And kind of the two big ones that I see most commonly is assuming that your data are symmetric and your data are normally distributed. And this is not uncommon assumption even in statistics to start there, because that's the easiest place to start. We have to start somewhere. But one of the issues is I think sometimes there's a lot of work that's developed that then kind of leads people to believe that we have good solutions for things without actually testing it on kind of data in the real world and seeing how that goes. So some of the work that I've done with my collaborators is really trying to test out the methods that people have proposed for doing differential privacy with, say, regression, and actually testing it on data that's really, really bad. I mean, bad from from an assumptions perspective. And your theoretical guarantees fall apart pretty quickly. Yes.
So I feel like one of the criticisms, at least of like the version 1 of differential privacy you use, is actually kind of the opposite. Like one of the criticisms I guess I've heard is like, this is a worst case guarantee. You're trying to hide like what's the kind of worst thing that can happen if I sort of remove one person from the database.
Yeah.
Like what's the worst case scenario there? And that I'm curious whether you're just thinking of particular mechanisms where you think sort of, because that doesn't care what your underlying data is. It doesn't care if it's a Gaussian, it doesn't care if it's symmetric, it doesn't care what it's from. It just says like swap out one data point and sample it from the same distribution, and what's the difference that you would expect. How does that gel with your description of here, where I imagine you're thinking about different theoretical guarantees that don't hold under common issues?
Yeah. No, that's a really good question. So I think that they're connected, right? So what often happens in the literature is because we have this very strong notion of the worst case, we then have to set fairly strong assumptions on the data domain to actually get something like that we can work with.
That's fair.
And so, like if everyone's familiar with the idea of the sensitivity of the function, right? Like there's lots of kind of tricks people use in their papers to bound the sensitivity, which in a lot of cases is not realistic to the way data are actually generated in the real world. But they are. I think it's actually a really good connection to draw that kind of because of the definition of privacy loss that we're using, it kind of ties our hands a little bit in terms of producing things that are viable, right? No, but it's a great question. And then the third one, which
Can I interrupt again?
Yes.
Question from the chat.
I love questions, so please keep them coming.
Speaking of the social sciences, do you think there's a gap of DP tools in native stats languages like Stata, R, SPSS, etc.? A gap of DP tools.
That's a great question. I don't know of any tools in those languages.
It's like just OpenDP.
Does OpenDP have R? I thought it was just Python.
Python.
Yeah, so as far as I know, if you're kind of like coming down the hierarchy of programming languages towards statistical ones, like I think Python is as far as you get. If, there are, I'm trying to think so like synthetic data, there's a number of packages in R, but I'm trying to think if any of them even do differentially private synthetic data, if they're doing it in the more traditional sense. I don't think they do. So yes, I would say to your question, the person online.
Oh, there is an R package.
Oh, is there from OpenDP?
Yeah, but I don't know if it has everything.
Yeah.
Anyway.
Yeah, no, it's a great question. I think there's probably a whole other talk that could be given about kind of perceptions of differential privacy in the social sciences, which, that's a whole other talk and a whole other huge issue that has to be wrestled with. But I'll leave that there for now. So the third point is about uncertainty estimates. So this one I think is, again, Kenny, you have to kind of nuance it appropriately here. A lot of the promise of differential privacy in the kind of the idea that was formulated is that if you are adding noise with known distributions, then you can quantify how much noise has been added and then account for that when you do your statistical analysis. But in practice, actually, this is kind of assumed that this is possible, and it's not actually shown how you can do it. So there's a ton of mechanisms out there that are going to give you, if I ask for the mean of something, it's going to give me the mean. But then if I ask for, a confidence interval, there's no kind of created way to do that. There's kind of an assumption that it's possible to do that, but it's not actually formulated in the paper or, in the literature or all these things. So, and a lot of that gets at something I'll talk about a little bit more later, but, you kind of have to have a lot of knowledge about the data generating process to get the uncertainty. But again, I think this kind of goes back to the unalignment, right? Like a lot of these mechanisms are not being developed with users in mind who are going to be needing uncertainty quantification. All right, so I think the result of kind of this set of issues is simply poor empirical performance, is what I'll say. So we did a big study a couple of years ago on, regression methods for differential privacy. I'm not really going to explain these charts that much, but basically the point is there's a huge amount of noise added, even at high levels of epsilon for any of the kind of existing methods for regression. And there's various reasons why, but they all kind of come back to the 3 points that I mentioned earlier. There's not a lot of work out there doing this, so there's not a lot of methods to actually draw on. And they are, of the ones that are out there, even fewer of them are giving you uncertainty quantification, so that narrows your options down even more. And then really the killer is that they're not designed kind of with the skewed data or outliers or all these things in mind. And so when you actually test them empirically, they perform quite poorly. Okay, so that's kind of the first set. I think that one is maybe a little more talked about in the literature, the idea that there's kind of a gap between the theoretical and the empirical performance of privacy. So I'm now going to spend more time on kind of a series of issues that I would call more usability issues, more issues around the assumptions that the framework of differential privacy kind of places on someone who's going to, say, use an interactive system. So these ones are also going to be a little more maybe specific to an interactive system. So the first one is that there's really a limited ability to perform exploratory data analysis. And this is a really important thing in social sciences, people working in public policy. And people can have arguments about whether or not exploratory data analysis can be abused, which it certainly can. But the reality is the research environment we live in uses EDA, and you can't just get rid of it. So the kind of on the flip side, differential privacy requires that you specify the function and the sensitivity of the function without absorbing the data. So you have to, come to the data with an idea of what you're going to query, and either, someone has to input the sensitivity of the function. But in practice, the domain of the data and the range of the outputs is often simply not known. Even if you give me, some kind of metadata, I won't necessarily from that be able to tell, how to specify my query appropriately. This also kind of has a downstream effect, thinking about an interactive system where there's really a lack of desirable means of error handling. So kind of in the classical differential privacy framework, if you can throw errors as, if that's a potential output of your function space, then you have to probabilistically throw errors all the time. And that's just simply a non-starter for anyone I've ever talked to in the social science space. Like they won't even consider that as an option. Because how do you explain to someone that their error is maybe not an error? I think there's one more, which is there's very little work that even exists on applying differential privacy to what I would call common EDA tools. So things like model selection, things like, diagnostic plots for models that you fit. These things are again, things that researchers in the statistical space are going to expect. And if it's not there, then there's really a disconnect for them as users of a system. And they're not really going to know how to use the system. And then I think kind of a cumulative effect of all of this is that even if you were able to do all your EDA with differential privacy, if we kind of lived in that perfect world, you would still be inducing an undesirable trade-off between correctly specifying your function and the amount of noise you're adding, which is really pretty undesirable, right? That like to actually get the right query I want, I have to add more noise to get there. I think that, again, this is, again, what I would kind of call a usability issue. The second issue in this set, there's going to be 3 or 4 of them, is setting the privacy parameters. So again, differential privacy assumes that we have some privacy parameters and that they can be set a priori, right? So when you specify the function, you also specify how much privacy loss is being induced from that query. But there's a few problems with this. So kind of on the privacy side, a lot of people have pointed out that there's not a consensus interpretation of the privacy parameters. So if someone says what should the privacy budget be for your queries, say you're going to set it to be the same for every query, there wouldn't be consensus on what that value should be. And a large part of that is because there's actually not an absolute interpretation of what that privacy loss actually means. It's a measure of relative risk, and so depending on what you're querying, the absolute risk is actually different for the same values of your privacy parameters. And then the last thing I'll say is that if you, from kind of the accuracy perspective, thinking about the user here, they are going to have a threshold at which they just don't find it useful anymore, right? So there is kind of a minimum level at which the person, who's requesting the query, there's a minimum epsilon for which anything lower, it's just not even a useful query for them. So we did a big survey a few years ago. That's what the plots on the right are showing, and we asked people, on a number of different metrics of accuracy, at what point would you just not even use the data anymore if it fell below this accuracy, right? And there's kind of this trade-off, or this dropping curve, where like the percentage of people who would use it at higher error tolerances goes down. And this is just one study. Like, this is not saying that this is the actual curve for everyone, but the point is there is a curve. And at a certain point, people will not find it useful. And so, this is, again, a usability problem. If you're setting up a system and you are determining, how to set your privacy parameters for each query, it's not easy to do that either from the perspective of what the privacy means or from the perspective of the accuracy. The third one, which is really connected to the second one, is, but I would say slightly different, is that there's a finite budget overall. And this is actually a really important thing, right? This is kind of one of the primary arguments for differential privacy, which is that we can actually account in a finite way for the privacy loss. It's not just some unknown or infinite number. But it really runs into practical questions, like what do you do when the budget runs out? And there are different proposals out there in terms of thinking about swapping out data and refreshing your data. I would say that those are really good and interesting ideas. They don't work as well in the space that I work in because there's simply a lot less data. And so the idea that you can kind of refresh your data doesn't work as well. And also people are much more interested in longitudinal studies. And so, for example, I work a lot with the tax data. And if you kind of said, well, we're done with anyone ever analyzing the 2018 tax returns, then anyone who wants to do a longitudinal study is basically sunk. So, some of these ideas don't really work as well in that space. And then kind of an adjacent issue is that, if you're going to kind of predetermine a privacy budget, to efficiently allocate it across a bunch of different queries, you would need to know all the queries in advance. But in practice, that's not true, especially if it's a validation server for people who, again, want to query, say, tax data. Like, you might have people in the future who come and say they want to use the system, and then you have to figure out what to do with their queries. That's kind of connected to the non-interactive versus interactive issue, I think. And I actually think it's probably a lot of the reason why people have been trending towards the non-interactive, even though we kind of know that in theory the interactive is better in that way. The issue of efficiently allocating the privacy budget when you don't know what's coming down the line is a pretty big issue. Okay. So I spent a lot of time talking about issues, and so I think at this point it's probably fair to ask, is a differentially private interactive system possible? I mean, obviously it's possible, but is it a good idea? And I would say really what I'm trying to do here is point out incompatibilities and issues right now that we have. I'm not making a value statement about whether or not we should be doing this. I actually think, again, from 10 slides ago, that there's a lot of reasons why interactive systems are important. But, kind of the way that these systems have been theorized requires maybe a different research environment than what currently exists, right? So either we would have to, imagine the research environment changing substantially, or we might imagine some compromises from both sides, right? So I think there's a need now and some I think desire to explore ideas for increasing the practical usability and kind of determining how we might do different privacy relaxations to allow that. There's a couple other papers that are pretty recent. Rachel Cummings is the first one, and the second one is Jeremy Seaman, who are also talking about these ideas, I think, really, really well and really helpfully. So I don't want to say again that I'm the only one talking about this, but I think that this is really where the field is starting to move in some ways, especially I think in the interactive space, because it's so complicated. Okay, so the rest of the talk, I'm going to be throwing out ideas, basically, about what if we tried this? I'll caveat it by saying they could be bad ideas. They could be things that we, eventually decide doesn't actually help any of the issues I raised. But the project that I'm working on, this is, again, the project for the IRS we're doing. That's kind of behind a lot of this work. We're kind of at the point where we've been spending a lot of time working on interactive systems, and now we're throwing paint against the wall. We're trying to see what works. But before I kind of throw out some ideas, I want to take a step back and try to be a little more clear about our design principles, right? So when we are building an interactive system, a validation server, I think there's really three principles that we're working with. There's the privacy assurance, the statistical utility, and the system usability. My Ludus, who worked with me this summer, created this little image, which I thought was funny, because he felt very strongly that the third pillar is quite weak currently, and I agree with him. So what do we mean by these? So I'm going to define this a little bit differently now than just kind of the differential private framework. I think a lot of what I'm saying is very similar to what you would find if someone kind of tried to explain differential privacy. But I think that if we're thinking about really a practical system, the way we define privacy assurance might be a little bit different. So what I have is three things. There's accounting. Can we actually quantify and track cumulative privacy loss of our system? There's transparency, which I'm saying is is the ability or the desire to articulate what is and isn't covered by privacy mechanisms. And I actually think this one is something that is more common, or sorry, it's a bigger issue than maybe you would be led to believe just looking at the differentially private literature. Because I think there's a little bit of a myth in the differentially private literature that we have end-to-end differentially private deployments. Pretty much all of them in some way or another cheat, because there are some things that are not covered by the privacy mechanism. And if you really go and dig into any of the deployments that have been made, you'll probably find some kind of hyperparameter tuning or some kind of decision that was made along the way that wasn't really accounted for. And that's fine. I actually think that's fine. I think what we just have to do is be able to articulate it, right? And I think some of the ways people have been thinking about relaxations of differential privacy also have space for this, or could grow into space for this. And that's why I actually, put it as kind of one of the aspects of privacy assurance. And again, without going into a lot of technical details, that's kind of what I'm trying to say. And then the third one is threat modeling, and I think this one's really important, even though it's going to be a post hoc, more empirical thing, because we have to have a way to meaningfully interpret the privacy risks, right? I think at the end of the day, we won't be able to build systems that simply tell people that their privacy is protected with an epsilon of 10 or whatever, because they're just not going to accept that as a meaningful privacy assurance. And again, lots of people are starting to, I think, say this and realize this, that we have to, even in differentially private systems, we have to come up with ways to actually assess the threat, to actually do a risk assessment, so that we can try to interpret the assurance that we're giving. All right, the second design principle is statistical utility. And again, this is something that gets defined many different ways in the literature, and so I'm giving you my definition. And again, I think this is really a definition particularly for an interactive system, and particularly for an interactive system of people who are trying to do traditional statistics. I think there are other ways you could define this in other contexts that would make sense. But really what I have here is capacity. So this is the relevance of the possible queries, right? If you, for example, in the federal statistical systems, design a query system that only does counts, and a lot of people are going to find that very unuseful. Because their research doesn't involve counts at all. And so kind of the breadth of the queries that you offer, what you're actually able to do is part of what I call statistical utility. The second one is coverage, and this is the ability to make valid statistical inferences. So this really gets at the uncertainty quantification that I talked about before. Can you actually give me, say a confidence interval for a statistic or something like that? And then the third one is power, and this is kind of the closest to what people might think of when they think about like accuracy. This is, more or less how much noise are you adding and how much is that reducing the effective sample size. Again, there's kind of different ways you can nuance maybe how you would define that one, but this is how I define it here. All right, and then our third pillar is system usability, and I will caveat this by saying I'm not a HCI expert or usability expert, but my collaborator has helped me think about a lot of this stuff, and so I'm largely drawing on his thoughts here. But I think we've tried to distill it into ways that should be pretty understandable for a lot of people, which is simply what's the design, how easy and efficient is it to interact with the system, what's how much knowledge or required expertise do users have to use the system. If we build a system where everyone needs to be an expert in differential privacy, that's probably not going to be a system used very heavily, at least in the federal statistical system. And then thirdly, the applicability. How well do the system's outputs meet the specified user's tasks? This one's a little bit different, I think, than what I was talking about before in terms of kind of the types of queries. This is more, how are the queries actually returned, right? What's the actual output look like? Is it output in a way that's interpretable by people who are maybe not as familiar, and can they actually use it for their downstream tasks? Okay. So now that we've got those principles, I'm not going to go through this. I'm just throwing this up here to give kind of a step back. So we kind of said, okay, big picture, let's throw a pin against the wall and come up with a system that tries to incorporate these design principles. So I'm going to walk through a few of the particular steps. And again, this is where I'm saying, throwing out ideas, and I would call these really open research questions that we hope to pursue. And if anyone here is interested, I would love to talk to you about them. So the first one is, in an interactive system, having companion synthetic data for EDA testing. And this is something at least one or two other people have talked about, but the way I would articulate it is maybe, it's not just providing data with the structure and the metadata, which is how some people have thought about it. It's really providing data with the same domain and similarity in output range. That's where the hard part comes in, is actually doing that. But the question is, if we did this, would it actually improve users' ability to correctly specify their queries? So this kind of goes back to my point earlier about the EDA issue. So is there a way that we can basically use auxiliary data to help people specify their queries in such a way that they don't face this undesirable trade-off between correctly specifying their query and how much noise is being added to the query? Secondly, can we help them specify their privacy budget more correctly, right? So one of the big issues with providing uncertainty quantification, one of the big issues with helping people choose their privacy budget is it's hard to give them kind of a priori uncertainty quantification. So it's hard for them to know how much noise is going to be added if they select a certain budget. But if you have synthetic data, you might be able to actually do some of that testing. And then one of the, kind of the big question on the flip side, if we actually wanted to do this, is how would we specify the queries to actually generate the synthetic data? I'm going to go through these kind of quickly, but if people have questions, we can chat. Second one is removing the privacy parameters. This is kind of flipping it on the head and saying, why don't we, stop asking users to input how much privacy they want for each query. The kind of the typical framework in the interactive setting is to say, here's your total privacy budget, and you can divide it up as you want, and you can, make those decisions yourself. In practice, I should have cited them, but there's a few papers that have tried to actually talk to users about how they would do this, and basically all the papers say that people don't know how to interpret these parameters or how to split them up, and they're kind of at a loss for what to do in the setting where they're just kind of told, here's your budget, use it as you will. So instead, a proposal would be to flip it on its head and say, if someone is, requesting a certain query, then they can also basically say what their threshold is, right? So if we think back to kind of the threshold of when is it useful, when is it not useful for someone, allow users to input that information instead, and then do the translation on the back end to what privacy loss that actually amounts to. And if you're wondering how that gets approved, I'll talk about that in a minute. The open questions here would be really, which metrics would users prefer to set, right? So that's a big one. If you're going to have people specify their requirements, there's a lot of different measures that could be made. One could be, what's the distribution of the, what's the expected bias? What's the, increase in the standard error? Like there's different metrics that you could use, and it's not obvious what would be the best one. The second one would be, if someone had to request this, could they actually anticipate the impact of these requirements for their downstream tasks? So basically, could they do this well? Could they actually specify their statistical requirements, or are we kind of imagining that someone would be able to do that? And then really, I think the important question is, does this actually improve the usability of the system, right? So does it just kind of change one thing for another, or does it actually make it easier for users? So a lot of these open questions are, I think some of them are research questions for people, in the privacy field. Some of them are really questions for testing with humans and actually, building these things and seeing if it works. Partner to the second one is to utilize a per research question privacy budget. So instead of, again, kind of the common framework, which is you think about each person or each user getting a certain amount of privacy budget that then they can split up for their queries. Instead, we might think about utilizing a per research question budget, where basically if someone comes and says, I want to study, I don't know, I'm not going to make something up on the spot, but imagine an economist or something who wants to study the tax code. They probably have an idea of the research project they want to do, and they have maybe a set of analyses that they need to do in order to conduct that research project. So they would actually put together a whole set of queries, kind of with their specified accuracy requirements. And then they would put together a justification. And one thing that's really appealing to me about this idea is that it feels a lot more like what I see working in an IRB. So there's a lot of balancing of value and risks when we do human subjects protection. And people come and say, we want to do this kind of study, this kind of survey, whatever it is. Here are the potential harms to people, but here's why it's going to be good and why society is going to benefit. And that's actually how we do, for those of you who haven't gone through the IRB process, we're not just we don't have an absolute standard of harm. We are always balancing against the value that the research is providing to society. And so this kind of frames the idea of a privacy budget more in that way, I would say, of saying, some research projects are going to require more queries and maybe more privacy loss. But maybe there's a reason for that. Maybe there's a justification. And so let's actually have that all kind of as one package. I think the open questions here are, again, usability. Can people do this? Does this help users efficiently allocate their privacy budget because they don't really have to think about allocating anymore. They can just think about doing their research and how they, what they need. And does this help us, efficiently allocate across the whole system, right? So rather than just assuming every single researcher should get the same amount, some people are going to need more and some people are going to be less. So maybe this is a more efficient way of allocating across the whole kind of life cycle of system. So the fourth one, which is going to, I think, naturally follow from the previous two, is that you're going to need a human in the loop. So this is maybe not surprising, but I think there are a lot of people who would say one of the real benefits of something like differential privacy is that you can automate it in theory. And I would say actually, maybe let's pump the brakes on that. And in part, let's pump the brakes so that we can kind of facilitate the two previous things that I was talking about. So, if you have this kind of package that's being put together that has, where people are basically specifying the research they need to do and their threshold for how much noise you can add, that's going to result in requests that are not feasible, right? So there's going to need to be a human who's going to look at that and say, sorry, we can't approve this request. And it also could potentially help with error handling. This is, maybe a trickier issue, but you could imagine a system where, basically the human gets a report about whether or not an error would be thrown by the queries that people want to submit. And then you don't actually have to return the error. You can maybe come up with a different system for handling that. So I think here, the big questions are really what are the processes and guidelines that would ensure effective and equitable evaluation. I think this, unfortunately, even though it has some benefits, it would also, of course, open us back up to a lot of human biases, which have a lot of issues. But I think the question would be, what are the processes and guidelines to try to manage that, as well as ensure consensus among the reviewers, right? You can't ever get away at the end of the day from someone having to decide whether or not the privacy loss level is acceptable. In this case, it's whoever the human reviewers are. And that's a decision that will have to be made. So what are the processes and guidelines to get to a point where you maybe have a set of reviewers and they have consensus about what's acceptable? And then, if you need to do iterations, right? If someone puts in a proposal and you say that's too much, how does that iteration work? Right? Is there some kind of feedback or how many times can you go back and forth? Because remember, one of the goals here in terms of usability is really to reduce administrative costs and burdens. And so, you can't have if the humans are doing everything, you're not really benefiting the system that much. All right, and then my last one is deliver statistical outputs and interpretations. And this is, I think, rehashing a lot of what I already talked about, but basically giving users outputs that include uncertainty quantification. One idea we did have that we're playing around with is, is it even possible to include some kind of pre-designed interpretation language, right? So that, if someone wants to go publish in a journal, there's like a little text block that they get with their query that tells them how to explain what happened, or how the noise was added, and why they should trust it or whatever. So I think open questions again here are, is it possible to do that in a way that actually helps users, and would this actually increase the adoption of the system or not? All right, so that was a lot. Kind of ran through a lot of different ideas, but I just want to leave kind of a few last thoughts, which I think kind of sum up a lot of what I'm trying to say here. The first one is, are we building systems that can be used? And I think that's a super, super important question to ask ourselves. I think there's been a ton of amazing work in the theoretical space, but it's really outpaced practice. And we need to really start working on, working out the barriers to the practical use of interactive systems. It makes me think of, I have a friend who is in physics. He works in theoretical physics, but he told me the other day that, it was like 50 or maybe not 50, 30 or 40 years ago that basically the theoreticians started doing things that the experimentalists realized they will never be able to test. And so he said there's a lot of people who are basically asking theoretical physicists to stop doing theoretical work because they're so far ahead of anything that they'll ever be able to test. Which is maybe a good question to ask, right? Like, at what point do we need to kind of balance these two things? And then the last thing I'll say is, I'm sure everyone has heard this before, but I hope that a lot of the stuff I've walked through has given you a practical kind of picture of why collaboration is key, right? The privacy engineers, the statisticians, and the user-focused researchers, are really all going to have a different perspective on what makes a system work. If we think back to those three pillars. And so, we really need to be, talking. That's why it's great to be here, talking to all of you, and trying to work out these problems together. Thank you.
There was a question in the chat. My chat. There we go. So speaking of threat modeling, do you see a difference in risks of membership information attacks or privacy leaks that would differ between interactive and non-interactive systems?
So I would say, I would actually say I'm not sure, because most of what I can think of in the kind of empirical threat modeling space is in the non-interactive setting. For example, it could exist because there's a lot of papers out there, but I'm not familiar with anyone who's, for example, done threat modeling based on the output of regression coefficients, right? That doesn't mean that this doesn't exist, but I don't actually know what that looks like. And I think, so I think maybe that's another question that we need to wrestle through is, if we can't come up with a realistic threat model, either we need to think about it more, or what does that mean? So that answers the question.
Yep.
I have one.
Yeah.
You pointed out that only LinkedIn has been able to create an interactive system. Like, what are they doing right in that sense that it's working for them at this point?
Yeah, so their system is. So there's a few things I would say that are different kind of in their system. Well, maybe one big thing that's different and one thing that is similar. So the first thing is that they are working in a more simple query space, right? Like, I actually can't remember exactly what the data set, I think it's engagement data.
Yeah, I think it's audience engagement.
Yeah. So I think they have pretty well-behaved data set in terms of, like, they know the sensitivity of the query. They know the queries, like the types of queries people want. They know the sensitivity of those queries. Like, it's a less complicated space than kind of open-ended social science research would be. But then the thing that I think is similar, which they're just handling it, the way that anyone has to figure it out, is like they do a per user budget and it gets refreshed, right? So there's, in terms of the kind of questions about the allocation of the privacy budget and the capping of the privacy budget, they're basically leaving that all up to the user, right? And so maybe that's working for their users. I don't actually know. I don't know if they have statistics on, like, how many people use it or how popular it is. But, I think maybe to sum up this long answer, it's not to say that that's not a way to do it, right? But I'd be interested to know kind of who's not using it because of that setup. Yeah.
Does an interactive system not dramatically increase your threat potential? Ultimately, if I put out a sanitized database and the database is lost, I only lost the sanitized data. If I create a walled garden and someone gets into that walled garden, everything is gone, right? So moving towards an interactive system, does that not dramatically increase risk?
So you're thinking about more of a like security issue
Yes.
in that case? Yeah, I mean, so I'm definitely not a security expert, but I would say, yeah, I mean, probably. I mean, I guess I don't know if it's, so at least in the space that I'm working in, I don't know if it's actually that fundamentally different because the people who are maybe creating the sanitized databases, they still have the confidential database somewhere. So maybe you're opening up new security risks by having an interactive system, which I would be out of my depth to know, how risky that kind of system is. But yeah, I mean that's a fair. Actually, now that you say that, the team that I'm working on, one of the other parts of the project is basically thinking about the security side of this, right? Which I don't have a lot of visibility on, but that is a whole nother thing you have to think about if you're letting people, query your data. Yeah.
If I may add a comment on this, so I should preface by saying I'm not really a differential privacy person, and I'm definitely not a like super knowledgeable, but I guess at least from the theory perspective that I know, there are many scenarios where you can get much higher accuracy from the interactive systems than from a sanitized database. So the reason that you would want to do it, at least from a theoretical perspective, is you can do, you can do queries that have a significantly higher accuracy for the same privacy budget with the interactive way, but not with the sanitized database way. But as you say, like as you kind of talked about at the beginning, that depends on knowing what the queries are, there maybe being a smaller number of them, or them being simpler, like counts, as opposed to the more messy, experimental data analysis, or anything else that you might want to do. So,
But it's so true, right? I mean, I think that is ultimately why people are still trying to do this, right? Like if you had a fully functioning interactive system, it would be much better for researchers, because then they could ask exactly what they want. Yeah.
can you tell us anything about what you are doing with differential privacy at the IRS?
Yeah, so I didn't think I really had time to go into that whole project, but I would say this is a large part of what we're doing, right? So I kind of told you the outcome without telling you the origin. So kind of the history of the IRS project is that, this project started even before I started working on it. I think it started in like 2017. And basically the IRS has an extremely restrictive data regime where I think like a dozen people total have access to the IRS data, which is understandable. It's a very sensitive data set, but it's also enormously important for a lot of public policy research, and so they basically really want to. They want aid to increase the way of doing this. So they're exploring different things. They're exploring synthetic data, for a non-interactive product. They're exploring a validation server, and that's what I've been working on for 4 years now. So we've built 2 different iterations of it, and kind of in tandem to that, we've done a lot of methodological research about like what is feasible in this space. So kind of a lot of the stuff I was talking about in terms of the misalignment between differential privacy and statistical methods, that came out of a lot of our methodological research, looking at like what can you actually do if you want to say do regression-based analysis. And then a lot of the stuff that I've been talking about kind of, in the last part of the talk is thinking about, the systems we built and then kind of looking at them and saying, okay, but where are the gaps, right? So one of the big gaps is how do you handle errors, right? That's still an open question, both for us and I think for most people. And also how do we set our privacy budget? So these are the questions. And so at this point in the IRS project, we've done a lot of groundwork, and now we're trying to really get super practical. Yeah.
I assume the dream there is to be able to do like privacy preserving data analysis of tax data. Like
Yep.
that's the dream. Do you know? I would assume the IRS releases some kind of heavily redacted or noised or something information about tax. Like we know something about taxes, I would imagine. I've never tried to use tax data, so I don't really know.
It's very restricted. So basically, there are so there's I think there's like two tax policy centers. One of them is at the Urban Institute, which is why they are kind of the origin of all this work. And basically, like the researchers at those centers have access. So if you ever look at like any news report that talks about like a proposed tax, law or cut or whatever that politicians are coming up with, they will only ever reference two different organizations who have modeled the impact of that, because those are the two organizations that have access. And then there's like a handful of other really famous researchers like Raj Chetty who also got access. So yeah, there's like a small number. And then yes, there's a heavily redacted data set from like 2012. I think that's the most recent one. And even that one you have to pay, I think, like $10,000 to get.